to begin with on the section we're working on, let's see if I can figure out how to move that thing out of the way. There it goes. Okay, so we did the first, that table. We went over that table. We didn't have time to go over how to do the savings plan formula. So the savings plan formula is a little more complicated looking than what we've learned. So what you have in your savings plan is this is a payment. You're going to make a payment like at the end of every period. Maybe it's every month, maybe it's every 6 months, that kind of thing like that. Everything else means the same thing. You got your interest rate, your APR, and then N, just like in the compound interest formula, is the number of payments that you make in a year, and Y is the number of years. So one thing that's important is Y, and this is a good thing to write down because this is a place where students mess up sometimes. Y must be in years when you do that. So what we're going to do is we're going to focus a little bit on how to use this formula. That's mostly what we're going to be looking at today, is kind of getting comfortable with the savings plan formula. Okay? All right, so let's go to the next page, and that's what I'll get you kind of going on. Okay? Now, this thing right here, I left something off on this, and we're going to look at this after 1 year. So you want to add that into this problem. I left off, the amount of time on this. This is kind of the same problem that we did on the previous page, but we're going to go all the way up to a year. So if you continued this table up to 12 months, you would get the answer that the formula is going to give you anyway. So let's go ahead and start by just identifying everything. So you're depositing $100 each month. So that is your payment. So you want to write down just kind of what everything's equal to. That's your payment. Okay. The amount is what we're trying to find. Okay. So in this problem, we're trying to find that. The APR is 12%. And remember, you need to change that to a decimal. So change that to 0.12. Okay, N is the number of times you compound in a year. So since you're making monthly payments, then you're going to make 12 payments in that year. Okay, so that's how that goes. And then Y is going to be the 1 year, like this. Okay, so that would be how everything is set up, is like that. So the first thing you got to know is what everything in the problem means. Okay. Now, what we're going to do on this together is we're going to get this set up. Okay, so what we have here is put in the payment. That's going to be $100. Okay, and then you go put this in like this. This will be 1 plus the APR, which is 0.12. Divide by N, which is 12, like that. And then N is going to be 12. And then Y is going to be 1. Minus 1, and then that's all going to be over the APR, which is 0.12 over 12, like that. So when you learn this savings plan formula, the first thing you got to get comfortable with is what all of these things are. You've got your interest rate, which has to be in a decimal form. You got your payments. Then you've got N is the number of payments you make in a year. And then we added 1 year in like that. Okay, does anybody have a question about how that's set up? Now, what we're finding is the amount afterwards. Okay, now if somebody doesn't have this handout, you want to get this handout and you want to take everything down. I've got handouts up here for 4C. Yes, sir. Parentheses, yes. Now the way I'm going to show that's what you need. Okay, just get all those handouts right there. Okay, and so what I'm going to show you guys to do is kind of on your calculator. It's hard to put this in one step for most students. So what I'm going to have you do is we're going to do those two parts on our calculator. So I'll pull up my calculator, and this is what you can kind of do. If you get to a point where you understand how to put it in one step, you can, but I'm going to recommend you just kind of do these parts right here. This part right here is already done. but let's just do this like this, and we'll try to write whatever decimals come out. So just do this on your calculator. Do the part that I have in yellow. 1 plus 0.12 divided by 12, okay? And then you can close the parentheses, raise that to the 12 power. 12 times 1 is 12. And then you got to get out of that and you got to subtract 1. So I recommend that you start with getting that thing done. And we're going to write down, you want to probably write down at least 4 or 5 decimals or you'll lose some accuracy. So I'm going to go ahead and just write down 0.1268250301. I'm going to just write down whatever comes out on the calculator. Because if you round this off like to 1 or 2 decimals, you're going to lose a lot of accuracy. And if you're doing your homework on MyMathLab, you're going to get them wrong, okay? So you got to just take the attitude, I need to get everything that comes out on the calculator, okay? Now, just do the part that I have in green. Just take the 0.12 divided by 12, and then that part right there will be 0.01. So I recommend that you kind of do those 2 parts. Now put it all together. What you can do now is you can just go 100 like that, multiplied by the 0.1268, 230301. I think if you use about 6 decimals, you're probably okay. And you get that answer, then you can divide that by 0.01. And then this would give the answer of the problem, which is going to be $1,268.25. Okay. So one of the things you got to be able to do, there's 2 things. You have to be able to get everything plugged into the formula correctly, but you also got to make sure that you know correctly how to use your calculator. And that sometimes is a hurdle you got to get past. Okay. All right. So what we did on this problem is basically what you're doing is if you made a payment of $100 every month, at the end of the year, this is how much money would be in the account. Okay. That's what that's basically doing on that. Okay. All right. Do we have any questions about that? Okay. Just a matter of getting used to the formula. This is a more complicated formula than compound interest. So that's how that would work out. Now, I want you all to just kind of try and see if you can do this problem yourself. And there's one thing I do want to mention because I don't want you to mess up on this part. Let's just kind of identify everything together. So the APR is 6%, but what do you need to do with that percent? Change it into 0.06, okay? What is your payment? It says the payment is $600, okay? Now, what you're doing is you're making a payment every month. So N is the number of payments you make in a year, okay? So that means you make 12 payments in 1 year, okay? That's what that is. Now, here's the thing that you can't mess up on. You don't put 18 there because what I said is Y must be in years, okay? That has to be in years. So it kind of goes like this. You would have to do a simple conversion. So 18 months, we can do a simple conversion. So we know that there are 12 months in 1 year. Okay, and see, that's like we've talked about all this unit conversion stuff. You just do 18 divided by 12. And if you do that on the calculator, that's going to be 1.5. So what you put in for Y is 1.5. Okay, so that's the only part of the problem that sometimes students have a little trouble with. Don't put months in. Y has to be in years. And then just you want to go through and see if you can plug it into the formula. You don't have to write the formula down. I'm just going to write it down. So as you're putting this problem together, you can kind of refer up here on the screen if you want to, or that formula I think is at the top of the page anyway. Okay, so take a few minutes to see if you can get this one set up, and then we'll see if we get a correct answer on it. Okay. So this will be kind of a good start. It's just seeing if you can get the savings thing put together, okay? I'll walk around and see if you have any trouble setting it up or if you have any trouble on the calculator. What I'm going to do is I'm going to go ahead and I'm going to write down what the answer is on this problem. And I just want to see if you can get that answer on that. Okay? All right. So I'll see just kind of how it's set up. Just get it set up in the formula. We'll take a look at that and we'll see if there's any issues with that kind of thing. Okay? And then try your calculator. The better calculator we have, the easier it is. Everything I used before, so what we easier to do. Yeah, so it's set up right. So as long as you can get the calculation done, it should be okay. Okay, that's good. That's set up right. Okay, it's set up right. Oh, you need to try that in the formula. You probably want to write it down, okay, in the formula first, okay, and then kind of focus on getting that in your calculator. Set up right. Make sure that that is a 1006, because the decimal has to be moved back to. Right. Set up right. Calculator will get the answer that I have on the board here. Try to get the right down formula and then see if we can get everything put in. Good. Just kind of do the denominator, the point, would be the 0.06 divided by 12. Okay. So what I would kind of do is I would do this whole part. Now, one thing you've got to do is you've got to make sure that that is in a big bracket like that. And you want to put that whole thing in your calculator. Parentheses 1 plus 0.06 over 12 raised to. And then on your calculator, you may, I'll have to kind of see how that goes. So, I think we got that in. So it's like 1 plus 0.06 over 12. Now get out of the parentheses, make sure that you're out of the parentheses, and then do the exponent, and then just do 12 times 1.5. And then get out of the exponent and subtract 1. But you've got to get out of the exponent by pressing that button. Now do minus 1. Okay, and then that's going to be the result of that. Right, so you got to divide it by that number, whatever 0.06 over 12. You get what I mean? Okay. Talk about the exponent. Okay. So on this calculator, it's this button right here. So you want to do that. Okay, and you can go like that. And then what you have to do on this thing is, since you're doing a calculation, since you're doing n times y, you're doing 12 times 50 times 1.5. And that's got to go in a parenthesis like that. Okay, so that's going to be the result of that. It's going to go like 1 plus 0.06 divided by 12. And that's that. And then raised to, and then you're doing 12 times 1.5. So that's what you get with this piece. So you're going to take the payment, 600, times that number, and divide by that. Okay, so try out so you get. How many people got the answer I have on the board? Yeah. Okay. All right, that's the big thing. Thanks for coming to class today. You need to talk to me after class, okay? Okay. All right. So you want to try to see if you can get everything put in. Now, this part right here is, and you want to write it down before you put it in your calculator. 600 is your payment. Then you have 1 minus 0.06 is the APR, divided by 12, raised to the n, which is 12, times y, which is 1.5. So you're going to do 12 times 1.5, and then minus 1. Okay, then it's going to be 0.06 over 12. So what you want to do is you want to kind of work it out in parts. You want to do that part on your calculator, record what the answer is. Do that part on your calculator, record what the answer is. Okay. You got what's going on the board? So I think there might be some calculator issues. That's why I want to let you do some problems in class. Well, write down what that is. When you get the answer to this part right here, write it down. Okay. And when you get the answer to that, write it down. Yeah. Okay? Okay? And then you'll know what to put in your calculator. Well, we want this. Get out of the exponent, by doing that too, minus 1. Okay. Okay. Now, you're going to take that, you've already multiplied that by 600, so take that divided by, put divided by right now, but you would have to put this in parentheses, 0.06 divided by 12. So we're going to do that. You didn't divide. No, you didn't. Yeah, but I'm not doing that. Oh, okay, because you don't want to do the 600. You want to do this, then multiply that by 600. Okay. Because see what you're doing is you're multiplying the 600 through this entire thing. Yeah. Okay. You have to do that part first. Now, if you try to do that, you'll get it. Yes, yes. Okay, so let me kind of help you guys with the calculator issues. Again, how many people got the right answer? Just be honest, okay? All right, and one of the reasons we need to get good with our calculator on this is because of that. So let me just show you what you need to do. First of all, the first thing I looked for on everybody's paper is, did you set it up right? Okay, and we did a good job with that. It's 600 times 1 plus 0.06 over 12 raised to the 12 times 1.5 minus 1, close your bracket, and then it's all over 0.06 over 12. So the first thing I noticed is some of you didn't take the time to write that down. Okay, you want to write that down. So if you're going to do when you're tested over this down the road, that's one thing I'll require you to do is set it up in the formula. Then the rest of it's your calculator. So this is what I was trying to get you all to kind of pay attention to. There's really 3 parts of this problem. Okay, these are the 3 parts right here. And you want to just do them separately. Now, if you can figure out how to do this in one step on your calculator, that's fine. But let's just kind of do this like this. All right, so what I'm going to do is I'm going to take my calculator and I'm going to do this. This is the part that most of you are having trouble with. Just put in parentheses 1 plus 0.06 divided by 12, close the parentheses, raised to the 12 times 1.5. Okay, now not all of you have a calculator where the exponent goes up into what we call a superscript. Okay, if you don't have that, you have to have that instead of parentheses. You have to get down from the exponent. That's why I'm going to use this right key. Then I'm going to do minus 1 like that. Okay, that's what you want to record. So that's 0.093928 9396 like that. So I just record it. Then if I do the 0.06 divided by 12, I'm going to record that. So that is 0.005. Okay, now you can finish up the problem. So what I'm going to do is I'm going to take the 600 multiplied by the 0.093928 9396, get that answer, and then I'm going to divide that by 0.005, and then that'll give the answer to the problem, okay? Now, I think I had, I put one too many decimals in there. So I had 0.0005, so the answer should be this right here, okay? Now, let me show you one other way you can do this. This is another good way to do this problem. Watch how I do this time, okay? What I'm going to do is I'm going to do the part that I highlighted in yellow. I'm going to do 1 plus 0.06 divided by 12, close the parentheses, raised to the 12 times 1.5. It's not a bad idea even to do 12 times 1.5 before you do anything else. Okay, that's the part in yellow. Okay, now, since that's already on my screen, I'm going to multiply by 600. I'm going to do that now. Then I'm going to divide by, I got too many numbers in there. Let me do that one more time here. Okay, all right, so one more time. 1 plus 0.06 divided by 12, like that, okay, raised to the 12 times 1.5, okay, minus 1, so you want to get that. You do that first, that's where you ought to start. Now this time I'll be careful, I'm going to put in a 600. See, this is kind of the way I have to use my mouse to do that. So I get this, then divide by, now do parentheses, 0.06 divided by 12. And the reason you have to do parentheses is because the calculator has to do the 0.0612 before it divides. Then you got it. Okay, so I kind of think a good way to do this is to kind of do it in this order. Do the part in yellow, then do the multiply by 2, and then do the division. Okay, unless you're confident that you can do it all in one step, then that's fine. Okay, all right, but that's one hurdle that you got to get past. All right, any questions on that? Okay, all right. So one thing I see when I teach the class is a little bit of misunderstanding of how to use parenthesis keys and so forth. Okay, so let's go to the next kind of situation here. So with this one, if you read the problem, it says at 30, Michelle starts a IRA, which is an individual retirement account, to save for retirement. So she deposits $100 at the end of each month, and that's real important. So it says, part A, if she can count on an APR of 8% compounded monthly, how much will she have when she retires? And that's, this number right there should be 35 years later, because it's 30 and 35 years later is going to get her to 65, okay? So the APR is 8%. What do you do with the APR? Change it to 0.08, okay? What's the payment? $100, okay? What's in? 12, why? Because you're compounding monthly. If you're compounding quarterly, it would be 4, okay? What's Y? 35 years, there you go, okay? So this sets up like this, okay? So what you do is you do the payment, then you have your bracket, and it goes like this. You'll do 1 plus the APR divided by 12, and then your exponent is going to be 12 times 35 minus 1, and be sure you write those brackets like that. And then when you divide, you're dividing by the APR over N like that. So I observed you guys were doing a good job of setting the formula up. So that's good. Now I am going to show you guys, how many people, by the way, have a TI-84 in this class? I'm going to show you guys, and this is kind of why it will be good to have a TI-84, is your TI-84 can do this problem pretty much automatically, okay? You don't have to go running out and getting an 84. If you don't have an 84, you're going to have to, get it set up in the formula and kind of do what we've been talking about. Okay, so what I would suggest to do right now is put this in your calculator. I'm going to go ahead and show you the way I kind of like students to think about doing this. I would do this whole part first, then I would do this part, then I would do that part. That's just kind of a good order to do that in, is like that, okay? So go ahead and put that in, and let's see if we can kind of get a little more comfortable with our calculator. So I'm going to put in 1 plus 0.08 divide by 12, close parentheses, raised to the 12 times 35. Okay, like that. And then minus 1. Get out of the exponent and don't forget about the minus 1 and get that. Okay, now you don't have to write this down if you do it the way I'm showing you right now. Okay, so that part right there gives you that. Now I'm going to multiply that by the payment, which is 100. So I do that. Okay, then divide by, now do the third thing. When you do the third thing, use a parenthesis key so that it'll calculate it like that. Okay, so there's your answer to your problem would be that right there then. Okay, so now you can record the answer. What we're going to have as our final answer is $229,388.25. Okay, all right, any question on that? Okay, all right, now let's go ahead. There's a little bit more we're going to do on the problem. Okay, now we're going to find the total payments. Okay, so here's what you have to do. You're making payments of $100. How do you figure out how many total payments you're going to make? You're making 12 payments a year, and this is 35 years. So what math problem do you do to find how many payments? You do 12 times 35, right? That will give you the total number of payments. Then you're going to multiply that by 100, okay? So if we do that, notice that on this problem, if you do 12 payments a year for 35 years, you're actually doing 420 payments of $100, okay? And then if you do that on the calculator, that's going to give you 42,000 like that, okay? So we've got that. And then that will give you the amount of payments that you did, so that's 42,000. Okay, so that's how much money you put into the savings account. All right, now let's think about how you figure out the interest earned. So the savings account gave you this much money, but you put in this right here. That's what you put in. So how do you find how much interest is earned? What do? You subtract those two numbers. Exactly. Good. So on this, what you want to do is take all of the money in your account, which is this big number. Then you want to subtract off the amount of money that you put in. And then if you do that on your calculator, then you'll get the answer. So the answer on that is going to end up being $187,388.25. Okay, so you look at the problem, you put in 42,000, this much interest was earned, which is a bunch of interest, and this is the reason it's so much interest, because it's 35 years. If once you get out into the years, you get in the 20s and 30s like that, you start gaining a ton of interest. So that would be how much interest is earned. Okay, any questions? Okay, you guys go to the next problem. Let's give that a try. Okay, and see what you get. I'm not going to write down the answers on this one, but I want you to just see if you can get this one set up okay. All right, now really what you need to do is just go to the next page. I don't know why I typed this the way I did. Just forget about that and got the next page is what you want to do. For some reason, I typed this kind of funny. So at the top of page 5, you want to see if you can get this problem put together. You're just kind of repeating what I just showed you, okay? Let's see if we can get this figured out okay. Or page 4, I'm sorry, it's the top of page 4 is what we're looking at. So what I want to kind of see when I walk around is I want to see if you're identifying the information okay. If you're setting up the formula, then we'll kind of see if you're getting the right answer on on that with the calculator. We'll see if we're doing a little bit better on the calculator part here. Then I am going to show the, after we do this problem, how your TID-84 will do the problem. Okay. We want to go to the next page. Okay. Okay, now that one right there, N is 12, because you're doing 12 payments per year. N is always the number of payments you make in a year. So it's 12, okay? Okay, that's the number of years, so it's 25 years. Okay. Y is always how many years, and Y always has to be in years. Okay, at the very beginning of the problem, you're going to use this one. Right, because that's how you're going to find the amount that's in the savings account. Once you find the amount in the savings account, then you're going to look at how much money you put into the savings. And that total, that's how you're going to tell how much interest you're going to. So if you don't forget about the denominator, that's right. So you're going to be careful about that. Okay, let's set up those. Now you need to go on this hand. Now this handout I did last time. So you need to look at the formula that we're using. Oh, okay. Okay, that's the formula that we're using right now. Okay. So I'd start that problem by writing that. Okay. So this part right here is the formula says N is Y. So N is 12, Y is 55. That's what you need. Okay. So I thought I'd get them to do the problem to write down the formula first. Fill out the problems and stuff, right? Unless you're doing your calculator. Okay, so that's good. That's good, so that's fine. Okay. Okay, the first thing you gotta do, don't do anything into the calculator until you do everything plugged into your formula. What you gotta do first, you absolutely gotta write this formula. All over APR. Don't do anything on the calculator. Focus on getting those numbers in. Okay, that's the number of years. Okay, so you figure out 65 minus 25 will give you 40 years. So you start saving at 25, 40 years later, you're going to do 65. Okay? Focus on seeing if you do that. So, first thing I want you to check is the answer. The part A should be $114,451.51. Okay? So if you want to write that down, you can if you didn't get that. So part A, the answer is $114,451.51. You have to get that right before you get the rest of it. Okay? So you're good on yours. Okay? Okay, did you get that? Okay, you're set up right, you're doing something wrong on your calculator. I just kind of suggest that you focus totally on that, then multiply by 75, then divide by that. Okay? And probably on your calculator, your problem was that -1 does not need to be in the next one. So you have to be careful about moving that out of the next one. See, that's an exponent. Okay, that's what we're messing up on that. Yeah. Okay, so your problem on this is you're forgetting about the 600. Okay, if you multiply that number by 600, or not 600, what is the family of 75? You take that times 75, I think you'll get the answer you're supposed to get. Okay. You got everything in your formula, see, except you forgot that part. Oh, that's what you forget. Okay, so here's the first thing I observed. If you're doing these problems, have the formula somewhere. Okay, you're not going to have to memorize this formula, but it's not a bad idea when you're doing these problems to just have it to your side and then get everything plugged in. Okay, you can't do the problem until you get everything set up. Don't just go straight to your calculator. That's what I saw some of you doing. Don't do that. And if you take like a test over this, which you'll be doing one day, then I require you to do two things: to write down the formula, what's in the formula, then the rest of it you go to your calculator on. Okay, so 75 is your payment. Your APR is 5%. That gets changed to 0.05. N is 12 because it's compounded monthly. And then you have to do the 65 minus 25 tells you that you're doing a 40-year account. Okay, like that. So that's what everything is. Now when you set it up, you're going to do the payment, 75. Make sure you have your bracket, 1 plus 0.05 over 12 to the 12 times 40 minus 1, and then all over the APR, which would be 0.05 divided by 12. Okay, so I'm not seeing too much problem with people getting it set up. Okay, what I'm seeing more trouble with is the calculator. Now I'm going to show you, if you have an 84, how you can do this problem. And if you have an 84 on a test, you would have to set it up in the formula, but the rest of it, you can put the numbers in the calculator and it'll do it automatically for you. Okay, that's a good thing to know how to do. So again, what I was showing you guys to do is start with the complicated part. Start with 1 plus 0.05 divided by 12, close the parentheses, and raise to that power. Now, some of you do not have a calculator that makes the exponent go up. If you don't have that, then what you have to do is you want to have that in parentheses. And I know some of you aren't doing that because some of you are using these kind of phone calculators that don't do that. If your exponent goes upwards, then you don't have to have the parentheses in there. The other mistake some of you were doing was you were putting the -1 in the exponent. You got to move out of it and then -1 like that. So if you guys could get this part done, you're going to get the problems right. This is what you're having trouble with. Okay, so you get this. Now what do I do with that number? Multiply it by 75. Okay, get that. Then what do? I divide by parentheses 0.05 divided by 12. You have to use parentheses keys if you do that. So what you're going to get is you're going to get the answer $114,451.51. Okay? How many people got that answer okay this time? Okay? That's not too bad. You got to work on that though. It is, exactly. But it's a complicated formula, so it's kind of hard to put it in one step. But knowing how to use parentheses keys is real important, okay? So now, total payments, well, you're making 12 payments times 40 years. So if you take 12 times 40, you can do this all in one step too. 12 times 40 just means that you are going to make 480 payments, and those payments are $75, okay? So if you do the 480 times 75, you made $36,000 in payments. So you wanted to get that answer. Okay, a 40-year loan or a 40-year savings account with monthly payments, you're going to make 480 payments. Okay, now interest earned, what do? You take the amount in the savings and you subtract off the amount of money you put in, and then this will give the amount of interest that's earned. So this would have been $78,451.51. Okay. All right. Yes, sir. No, because this problem right here said you start saving at 25 and then you retire at 65. Okay, so that means that if you take 65 minus 25, it's a 40-year savings. Oh, that should, okay, no wonder. Okay, that should be a 40-year period. Okay, that's my mistake. Okay, so what's that? That was a good catch. Okay, yeah, did you have something? Set up the formula. That's it. Okay, that's it. Okay, you do want to show what you're doing on the total payments and the interest earned. You want to show what you're calculating on that. Okay, all right, because I give partial credit. If you made one little mistake in setting up the formula, or even if you set up the formula right but got the answer wrong, then you're going to get partial credit. So you want to be careful about how you write stuff down. Okay, now those of you that have a TI-84, I want to show you what you guys can do. Okay, now you don't have to go buy a TI-84 because they're kind of expensive, but if you have an 84 right now, just do what I show you to do. First of all, find your apps key right here. You have an apps key right there, press the apps key. Okay, and when you press the apps key, you'll get something that says finance. Okay, when you get finance, press enter. You will see something that says TVM solver. Press enter again. Okay, now what you're going to do is you're going to put this stuff in your calculator. Okay, so in this problem, now it's a little bit different in the calculator. N is not going to be 12. N is going to be 12 times 40. That's how many payments are being made. Okay, that's 480 payments are made. So if you do this thing on a TI-84, the N is the total payments. That's 480 payments you make. When you put the interest in, don't change the to a decimal. Just do that. PV means present value at the beginning. At the beginning of time, there's $0 in your bank account, right? So we do that. The payment, you want to put in 75. It's a $75 payment. And then the future value, just put 0 in there for now. And then payments per year. P per year means payments per year. That's 12 payments per year. Compounding per year is 12. So you probably either want to, if you have a TI-84, you probably either want to take a picture of this on your calculator or write that down somewhere. It's the best thing to do is probably just take a picture. Then I'll show you how to do that. So you got to know how to put the stuff in correctly. The only things that are different is interest, don't move the decimal. And then N is the total number of payments, which is 480. Okay. All right. Now, if you got your TI-84, if you're with me, go get your cursor blinking on FV. FV stands for future value. That's how much money is your savings. Okay, identify this key at the bottom that says enter. It will have the word solve on it. So what you do, you have to be blinking on FV, then you go alpha, press your alpha button, and then solve, and it'll give you the answer automatically. It comes out as negative, but it's not negative. That's just the way the calculator works, okay? But that is kind of cool if you have an 84 and you're doing a test, and we're going to do a home buying project. We're going to start working on that next week. It's really nice to do this because you can check. You can check real easily. So how many had an 84 again? And by the way, I don't know if you can go to you can do a Google search and you can find maybe a TI-84 calculator to put on your phone, okay? And that might do this, okay? I use what's called Calculate 84. I don't know if it has that app on it, though. But if you've got a TI-84, that will allow you to save a little bit of time, okay? Maybe a little bit of time. Okay, let's go to the next page here. And what we're going to do now is we're going to work with the savings formula kind of backwards. Okay, so let me read this problem. Let's see if we can put this one together. Okay, so this one says that you want to build a $100,000 college fund. Okay, so you're wanting to save that. Okay, so what that's going to be is that's going to be the amount. That's your goal, is to have $100,000. A is your savings goal. Okay, and 18 years. So your time's going to be 18 years. And then you're going to make end of the month deposits. So you're going to make a deposit every month. So that means N is 12 again. Every problem I've done has been monthly, but you might see things that are quarterly and things like that. Okay. The APR is 7%. So you want to convert that to 0.07. And the payment is what you're trying to find. So I'm just going to put a question mark like that. Okay. So again, when we set this up, I'm just going to real quickly write down the formula. You don't have to write it down, but just for reference, when you're doing these problems, make sure that you are referring to the formula and you're getting everything kind of taken care of. And when you do enough of these problems, you'll get that formula memorized. So what we're going to do is replace the A with 100,000. Okay, so you're going to write down, you have 100,000 like this. Okay, that's equal to the payment. The payment we don't know, so that's a variable. Just leave it alone. Then you're going to have times 1 plus the APR, which is 0.07, over 12, so you're compounding monthly. And then your exponent is 12 times 18 minus 1. And then you're going to have all over 0.07 over 12 like that. So the only difference with this problem is we're kind of working in reverse. You're figuring out the payments, and this is practical. If you have a savings goal, you would want to know how much money I need to put in the savings every month. Okay, and this will figure out the interest and all that kind of stuff like that. Okay, anybody have a question about how it's set up? Okay, my observation is it seems like we're doing a pretty good job on setting stuff up. Okay, now what I'm going to do is I'm going to go ahead and I'm going to do these two things just kind of and get that answer on my calculator. So watch how I do this. So again, I like to start with the part that I highlighted in yellow. Okay, so I'm just going to put that in my calculator in one step. So I'll have 1 plus 0.07 over 12. Okay, like that. Then I'll close the parentheses and then raise that to the 12 times 18. Now, a lot of you need to put that in parentheses. I'm just going to put it in parentheses to be safe, okay? Some of you are making a mistake because your calculator is going to require you to do that. Then you get the minus 1 like that, okay? So you want to get that part taken care of and get the answer, okay? Now, what you want to do is you want to go ahead and divide that by 0.07 divided by 12. Notice I'm using parenthesis keys like that, and then record what you get. So I'm going to write down what we get in this formula. So bring down the 100,000, don't forget about it. That's equal to the payment multiplied by 430.7210266. Okay, like that. We have an algebraic equation that we can solve, and then we can get this okay. All right, does anybody have a question about what I did? Okay, what do I need to do to both sides of this equation to get the payment by itself? I got to divide by that number. So what you have to do now is you have to divide by that number because you're solving an algebraic equation. Okay, so that would be, just do that. Then we'll go to our calculator. Then we'll get the answer. Okay, so see, that's the reason we do that. You're going to have the payment by itself. And then I can pull up my calculator and I can do this calculation. So I do 100,000 and then divide by 430. 0.7210266, like that. So the payment on this is going to end up being $232.17 when I round that off. Okay, so you're doing this problem basically in reverse. You're just starting with a savings goal, but you do have to solve an algebraic equation. So you're going to get to a point where you'll have the 100,000 equals the payment times whatever that number is, then you divide by that quantity to get that. Does anybody have a question about what I did? Okay, all right. So we're going to do, I'll leave this up here. There's a couple of things on part B that we want to do, which is similar to what we did on the previous problems. So part B says how much of the total comes from actual deposits and how much from interest. Okay, so let's figure out, how would you figure out how much money you put into the account? What would you do? You're going to multiply these numbers there. You're going to do 12 times 18. That's how many payments you make. And what are you going to multiply that by? The 232.17. Okay, so you just do that. If you do that calculation, you're going to get $50,000, $50,148.72. Okay, so that's how you're doing that. Okay, now we're going to figure out the interest on this. So how do I figure out how much interest was earned on this $100,000 savings? I got to do two numbers. What are the two important numbers? 100,000. What's the other one? The 50,000 thing, right? Okay, so you need to do 100,000 minus the $50,148.72. So that's going to end up giving you $49,851.28. Okay, so what you want to notice on this is, I mean, all you're really doing on this is the $100,000. This is how much you put in, the 50,000. That's how much interest was on. Okay, so the idea is with the problem, you're just kind of doing that in reverse to find what payments are to reach your savings goal. Okay, all right. Does anybody have a question? Okay, all right, so go to the next page and I'm going to have you work out a problem, okay? And see if you can do it okay. So on this problem, you know, your savings goal is 75,000. So that's what your A is. And just kind of get it set up. I'll write down the formula just in case you need to look up here and refer to it. I'm going to go ahead and give you the answer to part A, just because I want, when you go through and work out the details, you need to see that you get the $164.98, right? So focus on getting it set up and see if you can solve the equation, okay? See if we're kind of beginning to get the calculator going a little bit. Okay, you got everything set up yet, so that's a good start. Good. You got to be using just the calculator, I think you. Yeah. And take that and divide by that, and I'm sure that comes into the numbers. Okay, that looks like that worked out okay. So Y is 18, N is 12, but they're doing payments every month, 12 months. And then the payments, what we're trying to find, A is the savings, which is certain towards savings. What is it for? So that's okay. You get that out of the calculator. You can say that you know that one. Okay. I mean, I don't give you kind of that whole calculation one step.
Yeah.
Well, that's helpful. As long as you want to put that in, okay. Looks like. I'll make sure that decimal is 0.075.
Oh, it's point
0.075. I'm moving the decimal back two places. And that worked out when you did it on the calculator. Just keep going. Be careful with your decimal. That will be 0.075. Now move the decimal back too. You always take the percent and divide it by 100. So how many people have gotten to the point where they figured out the 164.9? Once you get that, I think the rest of it's a little easier on your calculator. You get that okay? Okay. Well, you get that set up in the formula? I would write the formula down. That's a good one to start. Okay, you get that? You get that answer? Okay. Yeah, okay. Okay, all right. So when you get this put together, just a couple of mistakes that I saw. You got 75,000. Your APR is 7.5%. A couple of you did that wrong. If you're making mistakes about how you move the decimal over, just do this. Just do 7.5 divided by 100. Okay, that's what a percent is. A percent is just something out of 100. So that will give 0.075. Your payment you don't know. N is 12. You're doing 12 months. Okay, the amount of time is 18. Okay, so what you would have is you would have set up 75,000 equals the payment multiplied by 1 plus 0.075 over 12 raised to the 12 times 18 minus 1, and then all over the 0.075 divided by 12. Okay, that's how the problem gets set up, and I think we're doing that okay. When you do all of this calculation right here, if you do all that, I'm not going to pull my calculator up and do that, but you'll have 75,000 equals the payment. And when you do that calculation, you would have got $454. And I would just keep putting all the decimals in there. I know you get tired of doing that, but you're going to miss accuracy if you do that. So now it's just a matter of dividing by that number. Okay, and then you get that answer. So if you take 75,000 divided by the 454.6005603, you're going to get that answer. Yes. You okay? All right. So I saw walking around, a lot of you had like 454 there. That's the key to getting the problem right. Okay. Okay. So I think I'm seeing an improvement on the calculator. That's good. Anytime I teach this class, I always see there's issues with getting used to using order of operations on your calculator. Okay. So now the other part of the problem, when you're doing your deposits, this is what you should have done on your deposits. You're just going to take 12 times 18, that's how many payments or deposits you're making, times the payment, which is $164.98. So you're going to end up putting in $35,635.68. Okay, that's your deposits. Okay, if you want to find the interest, you have to do these two things. You're going to take the $75,000 savings minus the amount of money that you put in the savings account, and then that will give you $39,364.32. Okay, like that. Okay, so if you do this problem correctly, what will these two numbers always add up to? Where's your savings is? So those two numbers are going to add up to 75,000. So you can tell you're right. You really can. Okay. Okay. So we did pretty good with that. The next problem is an interesting problem. That has a little different twist to it. So what I've shown you is kind of what you need to be able to do with the savings plan formula. On the next page, the problem on the next page says you would like to retire 25 years from now and have a retirement fund from which you can draw an income of $50,000 forever. Believe it or not, you can figure this out. I mean, if you lived forever, you could figure out how much to deposit in this account so that you would have $50,000 even if you lived to be 1,000 years old. You can do this, okay? So let me show you how you do this. So the first thing is we need to figure out what the total balance needs to be so that you get that $50,000. So we have kind of a simple equation right here. We have $50,000 is 7% of the total balance. So we're going to solve an equation. This is going to be 50,000. Move the decimal to the left 2 to get 0.07, and then just put a variable like b or something like that. Okay? How do I solve this equation? What do I do to both sides? Divide by 0.07. Good. Okay, so we're going to divide both sides of this equation by 0.07. Okay, so I'll just pull up the calculator, and if I do that, I've got 50,000 divided by 0.07. This will give you the total balance that we have to come up with. So this is going to be B is equal to $714,285.71. So that's the total balance that we have to get. And then again, if we keep putting money into this, this thing will keep growing. But that's how you want to start the problem, like that. Okay? So you have to do that. So 7% of 714,285 is going to give you 50,000. So I did that kind of indirectly. Now, this is a formula. This is the same formula that you've been working with today, but it's solved for payment. So I would recommend, if you don't want to set up the equation and solve like you did on the previous problem I had you work, you can use this formula, okay? So what we're going to do in this problem is we're just going to set up this formula. We're going to do exactly what we need to do here. So A is the savings amount. So that's going to be the $714,285.71. Then we need to multiply that by the APR, which is 0.07, over, and let's see, we're making monthly payments. We're compounding monthly, so that'll be divided by 12. So that's your A times APR over N. Then divide by And see, this part comes from the original formula, so you're going to have parentheses 1 plus 0.07 over 12. NY, that would be 12 times. And then on this is, they're going to retire in 25 years, so the 25 goes there. Then we have the -1 like that. So see, this is the same formula, but it's solved for payment. So if you're doing your homework and you're asked to find a payment, you can just plug it into this formula if you want to. Okay, might save you a step on that. So when I do this problem, now here's kind of what you would want to do on this. You would really want to get this answer to the numerator, and you'd want to get that answer like that. Okay, so what you could do is you could just put in $714,285.71, and then multiply by, and to have this in parentheses, so the calculator can do the 0.07 divided by 12, like that, and just get that worked out. Okay, now you can write that down if you want to, but you could also finish up the problem if you were careful about how you did your parentheses. Okay, so that's what the numerator is. Now, if you want to do it this way and save a little bit of writing, now you can just divide by, and you can try to put it in like this. You have to double up on the parentheses. The brackets, you're going to use a parenthesis. So we're going to have 2 parentheses. Then you'll have the 1 plus 0.07 divided by 12, close the parentheses, raised to the 12 times 25. I'm going to put that in parentheses, just kind of, some of you have to do that. That's what I've been explaining. Then bring that down, the -1, and then close the parenthesis like that. Okay, so what's going on that then is I've got, if you want to do it this way, you can, or you could just record what the answer to that denominator is anyway. So if I put this in, this will give me $881.76. That's the answer to the problem. So what happens in this problem is if you started your savings and you kept putting $881.76 into savings, and you kept doing that even when you retire, that would guarantee that you would always be able to get $50,000 drawn out of this every year. Okay, even if you live to be 1,000, if you still keep putting 881.76 in, you're always going to get 50,000 drawn out. That's weird, but it works that way. So you could figure out how to figure out what you deposit to make that happen. Okay, so that's a little bit different problem, but the key is you have to figure out that 714. Okay, does that make any sense? Yeah. Okay, so what I did is I solved this equation right here. So you need to figure out $50,000 needs to be 7% of some number, and I'm just going to use that as a variable. You're solving this equation. So what I'm doing is I'm doing 50,000, 7% is written as 0.07 times b like that. Now I'm solving that equation, so this is just dividing both sides by 0.07, and when you do that, you're going to get that number right there. And that's what you have to use for A. So if this was a problem and your goal was $100,000 a year at 2%, you would do 100,000 equals 0.02 times B. And that's the key of the problem. You have to figure out what that amount needs to be. Okay? All right, anybody else have a question on that? Okay, all right, we're going to probably run through and talk a little bit about, kind of get out of that formula, and then we'll get through kind of thinking about total and annual returns. And this is a little bit simpler. It's with your calculator, it's a little simpler. So what the idea is, a total return, so if you have an investment and you have an original principal that accumulates to some amount, the total return is just found by doing this formula. And you guys have seen this formula before. That really is the relative rate of change formula. So you're taking the amount minus the principal divided by the principal. The times 100 just moves the decimal to the right too, so it changes it to a percentage. okay? The annual percent yield that we call APY, and you'll see this if you start kind of shopping around for savings, they will advertise annual percent yields, okay? So this is going to be found by this formula. You do A over P raised to the 1 over Y power minus 1. And then you can turn that into a decimal, the decimal into a percent. So let me get you kind of comfortable to kind of finish up here today on how these formulas work. So example 5, it says you invest $3,000. Over 4 years, your investment grows to $8,400. So which one is A and which one's P? That's what you got to understand. P is the future, right? Okay, I'm sorry, I said that backwards. A is the future. So A is going to be what that's going to be. P is going to be at the beginning of time. Okay, so write down in the answer blank that this is $8,400 there, and then $3,000 there. Okay, and then we're just going to do exactly what the formula tells us to do. So when we do the total return, you're going to do the A minus the P, divide by the principal P, then you're going to multiply that by 100. Okay, and again, with this thing, you can pretty well do this all in one step on your calculator. If you want to do it like this, you can. You could just do parentheses 8,400 minus 3,000, close parentheses, and then divide by 300. And this part right here is just going to give you 18, and then multiply. Whoops, I think I did the wrong thing, didn't I? Okay, so that would be, I'll do it a different way this time. I do 8,400 minus 3,000. Okay, I'll get that, make sure I get that okay. Now I need to divide that by 3,000. I don't know why I didn't write that right. So I do 3,000. Okay, now I'm good. So I get that. So what you're going to have is you're basically going to have 1.8 multiplied by 100. And that's going to, when you multiply by 100, it just moves the decimal to the right. So that means that the total return is 180%. Okay, so this formula is pretty simple. You're just doing the amount minus the principal divided by the principal. The times 100 is just telling you, reminding you to move the decimal to the right. Okay, when you do the annual return, so the formula for annual return, just follow what it tells you to do. Do A over P, so you're going to do 8,400 divided by 3,000. The exponent is 1 over Y, so Y is 4. You're given in this problem that's 4 years. Then you subtract 1. Now, I would recommend when you do this, just do it all in one step on your calculator. So just go like this. Just put in parentheses, 8,400, and divide by 3,000, like that. Close parentheses. And then raise to, and again, I'm just going to put parentheses to be safe. Then you can put 1 divided by 4, like that. Then be sure that you get out of the exponent and then subtract 1. So that's how that has to be put in your calculator. So this is going to give you 0.29, and I'm going to just round that 3 to 4 like that. Okay, so if you do that, you can move the decimal over to get 29.4%. Okay, so that's what the annual percent yield is it's giving you that percent amount. So these formulas right here, I think they're easier to do than the savings loan formula we're working on today. That's how you find a total return and an annual return. So a couple of things I want to mention on this too, to kind of finish this up. If the total return is 180%, then that means that it's 1.80 times its original value. Okay, that's what that means. Now I want to show you something on your calculator, and just watch this real quick. And let me show you what this really means. So if I take 1.8, I'm taking 180% of 3,000. Look what I get. Okay, I get 5,400. But notice if you take the 3,000, which is your principal, plus that 5,400, what you're going to get is you're going to get what that final amount is. So that's what that's doing. So what you're really doing with a 180% total return, you're doing 1.8 times the principal to get the 5,400. And then if you add that to the principal, you get the amount. Does that make sense? Okay. All right. Okay. So that'll get us through about really the majority of this. What we'll be doing next time is we'll start mortgages. So mortgages, a totally different formula. So we'll start learning how mortgages work next class. Then I'm going to give out your